What's up, everybody? Mr. Jones here. We're going to be doing some more factoring. We're going to be doing kind of a mixture, a combination of everything we've talked about thus far in terms of factoring. So we need to look for a GCF, okay? We need to look for dots. We need to look for when to use tic-tac-toe and that group factoring, right? So all the different strategies we've gone over thus far, we're going to apply to these, okay? And I'm not giving you much structure here, right? I'm not telling you which strategy it is, okay? So that's part of the challenge, is looking at the polynomial that we have and determining which factoring strategy we should use, okay? And sometimes there's going to be more than one within the same problem, so lots to look out for here. Okay, so looking at number one here first, we have 2x squared minus 50y squared, okay? So again, first thing you should look for in a group, no matter what size it is or how many terms, okay, you look for a GCF, okay? And again, there can be a GCF containing the same, if the terms contain the same variable, or if the terms contain a similar factor within the coefficients. Yeah, there's lots of things we could factor out, okay? In this one, again, a giveaway that there's a GCF amongst the coefficients is when all the numbers are even, right? So this one just has two terms, and the coefficients are 2 and 50, right? Two even numbers, and so obviously we can say that there's a GCF of 2, right? They share a common factor of 2. So when there's a GCF, right, I can factor that out by dividing each term by the GCF, and that is going to be reverse distributed. So that is going to be reverse distributed right from this group. So we would say 2 times, and we would divide, right? And so we'd have x squared, right, because 2 divided by 2 cancels, and then minus 50 divided by 2 would be 25, and then that y squared comes down, okay? So that is successfully factoring out this GCF, okay? But I do have to make sure, I have to look at what's left, and I say, okay, can I factor that again using one of my other strategies like dots or tic-tac-toe or group factoring? And you look at this, and we can factor that again. Okay, we can factor this again into two smaller groups using dots, right? Dots, difference of two squares, right? Meaning that this is a perfect square minus another perfect square. And again, all perfect squares can be broken up into something times itself, right? So x squared, we could say x times x equals x squared. 25y squared, we could say, right, 25 is 5 times 5. And then y squared is y times y, right? So we could say 5y times 5y equals 25y squared, okay? So these are both perfect squares, and so that means I can factor this and write it, right? So putting it all together, the 2 from before, and then breaking this up into two smaller groups, right? So I would break it up into x plus 5y, and then x minus 5y, okay? So that, I dropped my marker and got marker on my shirt. But yeah, so that is the fully factored version of this, right? I factored out the 2 GCF and I factor the rest using dots, okay? So that is number 1. Number 2, we look at this, okay? Trinomial, 3x squared plus x minus 14. Okay, so I have this trinomial, okay? First thing to look for is a GCF, okay? Are there any common factors, okay? They don't all have an x, so I couldn't divide out a variable. And my coefficients would be 3. I can write this in as a 1. So 3, 1, and 14, negative 14. No common factors there other than 1, so I can't divide out a GCF, okay? Now when I think about the strategy that I would use to factor, most often with a trinomial, I'm going to use that tic-tac-toe method. So let me jot that board down. All right, and if you remember, with that tic-tac-toe board, I write my first term in the top left, my last term in the middle, and this middle term is kind of my check term here at the end. And so now I fill in, right? I fill in these boxes, right? I'm wondering what times what equals 3x squared, and that would only be 3x times x, right? And then for negative 14, I'm thinking, okay, what numbers multiply to give me 14? And you can jot those down on the side. Okay, so you could say 14. You could say 14 would be 1 times 14, 2 times 7, right? But again, this is negative 14, so we have to take that into account, right? Um, so let's just pick one of those. Again, I said usually start with the one that's closer together, okay? So 2 and 7, okay? So let's just write that 2 and 7. And again, let's just make one of them negative. Let's make 7 negative, okay? Because one of them has to be negative because this is a negative 14. So 2 times negative 7 equals negative 14. So we go over here and we check, okay, if I multiply across, 3x times 2 would be 6x, and then x times negative 7 would be negative 7x, okay? And then when I go to add these, I check to see, okay, do these two terms add to give me 1x? And unfortunately, no, we're very close. Negative 7 plus 6 equals negative 1, not positive 1 like I want it to be, okay? So that means I'm pretty close. Let's try to flip around our signs, okay? Let's make the 7 was negative before. Let's make the 2 negative, okay? And so I'm doing 3x times negative 2 would give me negative 6x, okay? And then 1x times 7 gives me positive 7x. Now when I add 7x plus negative 6x, I do get positive 1x. So it checks out, okay? And again, that means my groups would be on the diagonals here, okay? So 3x plus 7 is my one group, and then my second group is the other diagonal, x minus 2, okay? So that would be my answer to number 2, factoring that using the tic-tac-toe method. All right, I'm going to do a few more with you using some different strategies. I'll put them up here right now. All right, now looking at number 3 here, 6x squared y squared minus 4xy squared minus 12x squared y. Wow. Okay, so first thing, hopefully you obviously notice that these have lots of common factors, okay, within the variables and the coefficients. There's a common factor there too. Okay, so we're going to deal with that GCF first, okay, and then we're going to look at what's left and see if we're able to factor it again. Okay, we may be able to, we may not be able to, okay, but got to take care of the GCF first. So coefficients out of 6, 4, and 12. Out of 6, 4, and 12, the highest common factor that those all have would be 2, right? Like I said, they're all even, so that's a giveaway. They have 2, but we couldn't say like 4, right? Because 4 times something doesn't equal 6, or at least for whole numbers, right? So 2 is the highest common factor for my coefficients. And then my variables. Now here's what's tricky, okay? Again, what we would look for is the highest amount that they all have, okay? Or another way to say that would be, what's the lowest exponent on any of the variables for any of the particular terms, okay? And what I would do is, right, so a lot of these have 2 exponents, but the ones that don't have an exponent, would it get a 1, okay? So they all have at least one x and y, okay? But they all, right? We would for the x terms, we would say just x to the first, okay? Because they all don't have 2, okay? This one just has 1x, right? Or an x to the first. So we wouldn't say x squared for the GCF because they don't all have 2 x's. And then same with y's, right? This one has 2, this one has 2, this one just has 1. So they don't all have 2 y's. This one just has 1. So we would just say again, what do they have in common? And the highest that they have in common is they all have at least 1. So we could say 2x to the first, y to the first, or a little more simple, just 2xy. Okay? And so once I determine that GCF, I divide every term by that. 2xy, 2xy, 2xy. Okay, I divide everything by that, and again, my answer I'm going to write as like the beginning of a distribution with that GCF on the outside. Okay, so now I just go down the line, one term at a time. Okay, 6 divided by 2 is 3. X squared divided by x to the first would just be x to the first. Again, if this is confusing, you can think of this as 6xxyy. Just kind of cancel out one of the x's as you divide. Okay. And then y squared divided by y would just be y. Okay, so I divided that. Minus 4 divided by 2 is 2. X to the first divided by x, they both cancel. So this term's not going to have any x's. And then y squared divided by y, so there's just one y left. Okay, minus 12 divided by 2 is 6, okay? X squared divided by x would be x, and then y to the first divided by y. Those y's cancel, so just x, okay? And now I look at what's left in this group right here, and I think, okay, is that going to factor? Can I factor this again? No, I can't, okay? And I can't really even combine any of these terms because they all have different amounts of variables. So this is actually as much as I can factor this, okay? I can't factor it any further, but I did pull out that GCF, and so that was a success. We did factor it, okay? Now moving on to number 4. Okay, now number 4, there's 4 terms in here, okay? And you might notice with this one, like right away, oh, there's 2 terms in the middle here that I can combine, okay? And yes, you can, okay? So you can actually go 2 different directions with this one, okay? You can either factor it using tic-tac-toe, and to do that, you would combine the 2 middle terms, and then, again, follow that same process of tic-tac-toe. But I'm going to show a different one here because I did in my previous videos. There's something we can do called group factoring, okay, which is also a strategy we can employ with this one, okay? So just to go over another strategy, I'll do it the second way, okay? Now, something that you could notice right away here is that if you look closely, you might not notice this, and if you don't notice it right away, you could still get the problem correct, but 9, 18, 3, and 6 are my coefficients here. Those all have a common factor of 3, okay? So I could divide all of these terms by 3 to start and factor out that GCF, okay? So if I divide all these terms by 3, I'd be left with 3x squared minus 6x minus 1x plus 2. Okay. Again, if you did not notice that, or if you don't notice that with a problem, you can still get it correct. You'll just have to know to look for the GCF at the end. Okay. So it's not like a deal breaker, but it is helpful because all these numbers are smaller now, and it makes it a little bit easier to deal with. Okay. So I factored out that 3. And just a note, if you did it the tic-tac-toe method, you would have to, right, you would notice there is a GCF there too that you would have to notice. Okay, so whatever strategy you do, there's a GCF of 3 amongst these terms, okay? But now I look at this group, okay, and I think, okay, I'm going to factor that using group factoring. So again, what that means is I take the group of 4 terms, okay, and I break it up into 2 groups of 2. Okay, so that means I just break it up right down the middle, okay? And I just focus on one of these groups at a time. So I just look at this first 2 right here, and I think, all right, GCF, I find the GCF of these 2 terms, okay? So out of 3x squared and negative 6x, okay, out of these 2 terms, the GCF there would be 3x, right? They both have an x, and then out of 3 and 6, common factor there is 3, okay? And so what I do, like I always do with GCF, I divide both terms by that, okay? And then I'm left with, I'm just going to ignore this initial 3 that I factored out from the beginning. I'll write it in my answer at the end, but just because I'm only really worried about this group right now, I'll just leave it off. So I'm left with, right, this 3x that I'm factoring out, and then I divide, right, so 3 divided by 3 is 1, x squared divided by x would just be x, okay? And then minus 6 divided by 3 is 2, x divided by x cancels, okay? So I have x minus 2, okay? And now this is the step where it's crucial, right? This is a really good check step, okay? Because right here, right, I want when I do the same thing to this side, I want the groups to match each other, right? I want this group to also be x minus 2, right? Because from there I can write my answer, okay? So I look for a GCF, though, out of these 2. And what's interesting here, right, negative 1x and 2, not really any common factors here other than just 1, right? All terms have a common factor of 1. But if I divided both of these by 1, right, dividing something by 1 doesn't change the term, right? So it would remain negative 1x plus 2, and that would not match, okay? But so, and I've mentioned this in my other videos too. You can make that GCF a negative when you divide it out, okay? So divide everything by negative 1, okay? Again, that's still the same as long as you're dividing both terms by that. and writing that -1 outside of here, look what I'm left with. -1 divided by -1 is +1, and again, x is there, so x. And then +2 divided by -1 gives you -2, okay? So that works, and I needed that -1 to be factored out for the groups to match, okay? And then again, writing your answer from here, right? Once you confirm that these two groups match, okay, those matching groups make up one of your answer groups, okay? And then your other group is the two outside GCFs, all right? So 3x minus 1, x minus 2, and then again, don't forget that 3 that you factored out at the very beginning is included in the outside, okay? So I know that's a lot of work, okay, but for this one, it might have been easier to factor using tic-tac-toe, but again, I just wanted to show you the other method just because I did teach you that too. Thank you for following. Good job. Factoring is a tricky thing, so I hope you get it, and thanks for following. If you need another video on this stuff or any other types of factoring problems that are confusing or that you're seeing that I didn't address, let me know, and I would love to make another video for you. So thanks.